Well, I eliminated the third session, so I still have 22 minutes for this fourth session. Should be able to make it. Alright, so how to implement P. This P is the label we give to our PDA that we're trying to design that behaves like a grammar, that uses substitution rules to modify an intermediate string, substituting variables for the right-hand side of substitution rules whose left-hand side matches the variable that you're substituting. Okay, well, here's sort of the algorithm, like an algorithm for non-computer science guys. Well, I guess by now you're getting that way already. An algorithm is just like a step-by-step recipe, do this, do this, do this, to achieve some goal. Well, here's the algorithm here for our PDA P that we're designing. So step one is push the $sign onto the stack and the start variable. Okay? So now on the stack you have, on top you have the start variable, capital S, let's say, and below that you have the $sign. So that's step one. Okay. Now at the top of the stack you have a variable. It's the start variable, but it is a variable. So that means you can then substitute it by the right-hand side of some transition rule, whose left-hand side is the start variable. Now you may have several. Now if you have several, if you have more than one, then then you go into part two. So three parts to part two. So repeat the following steps forever. Okay, so you just keep looping through this. Now, if the top of the stack's a variable, in this case it is. If you just come from 1 to 2, instead of just looping infinitely 2 to 2 to 2 to 2, but if you're coming directly from 1, then the top of the stack is the start variable. So then you can go looking in your big R of your grammar, the set of transition rules, substitution rules, and if you find more than one that has on the left-hand side the start variable, S, usually big S, well then you can non-deterministically, you can make copies of the machine, your PDA, and in one of them on your stack you can substitute, you put the right-hand side of the substitution rule you're using, and in the other one, or several, you put the right-hand side of the other. Let's say you have two rules that match. The left-hand sides are the start variable. Let's say you have two of them. Well, so you make two copies of your PDA, and in one of them, on the stack, you put the right-hand side of your first rule that matches, and on the second copy on the stack, you'll put the right-hand side of the second rule that matches. Now, don't forget the complication that what's on the stack in this PDA, it always has to be, the top of the stack always has to be a variable. Okay, so if the right-hand side begins with terminal symbols, then just match those terminal symbols with the input string. Okay, so if for example the first two symbols in your right-hand rule terminals, well then just read the next two symbols in your input string to see if they match the two terminals in your right-hand part, and if they match, fine, continue. If they don't, that branch dies. Okay, so that way, now if it is continue, if they do match, then you now have a variable at the top of your stack. Okay, so that's if the top of the stack's a variable symbol, then non-deterministically, for each rule that matches that variable, okay, and then substitute. In other words, pop the variable and then push the right-hand side with the initial terminal symbols removed. Okay? Once they've been checked, of course. If they don't check, well, that whole branch dies. But if assuming they've checked, okay, then your top of your stack will now have a variable. That's the first variable in the right-hand side of the rule that you're using for the substitution. Okay. Yeah, well, that's what I was saying here. So if the top of the stack's a terminal symbol, so read the next symbol from the input and compare it. If they match, repeat. What does repeat mean? I suppose that means pop. Yeah, so you read. Okay, so you're reading the next symbol. If they match, pop it. So okay, so there's one less. Right. If they don't match, reject. So that branch dies. Okay, so reject on this branch. Okay, now near the end, let's say you keep doing this. Go on forever as long as necessary. Keep doing it until eventually you have a string of symbols in your stack. And if they're terminals, you keep popping them and comparing with the string in your input, comparing with the input string, until eventually there's nothing left in the stack. Okay, so imagine you do your second last substitution. So let's say you're about to do your second last, and you have a couple of terminals in the right hand side of the substitution rule that you're using. You have a couple of terminals and then a variable. So you'll eliminate the let's say two terminals, and so now the top of your stack is a variable, and you substitute that, and that's the last time you substitute. And now what you've got on your stack, they're just all terminals. Okay? Well, then you just compare the terminals, those terminals symbols, with the corresponding symbols in your input string, and if they all match, then eventually, and each time you're comparing, the top symbol, if it's a my wife and I, we call the upstairs apartment the divorce apartment, because we've been here 2.5 years, and we've been through 3 couples, and the first 2 got divorced. So we heard, for a time, just horrific arguments. Sometimes so violent, things are crashing, and we were wondering, should we call the police? Anyway, so this is now the 3rd couple, and they're still renovating and modifying things and using the drill. Okay, all right. So imagine then that what's in the stack, they're just all terminal symbols, and so you pop them one by one and compare each time with if the symbol at the top of the stack is equal to the next symbol to be read in the input stream. And so eventually you keep popping the stack until eventually the last thing to be popped is your $sign. Okay, and in that case you've got an accept for that particular branch. Okay, so the